we're here to discuss a lemma that intuitively makes sense, or at least it will once we unpack the notation. But if you have a function with the limit w naught, where f is defined on some region g, and g naught is a subset of g, and z naught happens to be an accumulation point of g naught, then if you restrict f to g naught, then the limit doesn't change, is basically what it says. So let me give you a calculus example. I'm going to give you f of x equals x squared, where f goes from the real numbers to the real numbers. In other words, g is equal to the real numbers, right there. C becomes r because this is a calculus example. And I'm going to let, we also know that the limit as x approaches 2 of f of x equals 4. Right, so there's my w naught, and there's my z naught. Okay, then I'm going to let g naught equal, let's just look at the positives. So conceptually what we're talking about here is, here's f, and here's a graph of f naught. The graph of f is the parabola that we know and love. The graph of f naught is just half the parabola. What this theorem says is if you take a limit as this thing approaches 2, you get 4. This lemma says that if you do the same thing for f naught, if you take the limit as it approaches 2, you get 4. As long as 2 is an accumulation point, which is normally when you would naturally even try to apply this, so it's perfectly fine. So let me show you what this looks like in complex analysis. In the complex plane, you might have some region G, and this is the complex plane, and maybe here's the point Z naught. And then you might map it over with F, and then whatever happens is that you end up with some point, some other region, f of g, and you get the point w naught. And these two things are limits. So what happens, just to tell you a little bit, if this is g, this might be g naught. And it basically says, hey, if you just forget that the rest of g exists, the limit does not change. Right? Over here, the limit as x squared, if you only consider x on the positives, at 2 does not change if you ignore the negatives. It's still the same thing. That's what the lemma says in a nutshell.